Today's lesson is on mid-segments. I ran a quick Google search for mid-segments. I came up with some interesting pictures. One is of this, I don't know, android, robotic, something or another. Apparently this is about midway through the technical design of this sort of transformer, robot, android thing, whatever. And then what they're going to do is they're going to add extra pieces or components or shading or something to him to make him a little bit more complete, but he's at the mid-segment phase, I guess. As far as this goes, this is sort of a mid-segment hatchback, not the most expensive, not the least expensive vehicle on the market for this, but I guess it's a mid-segment vehicle. This is a dog on ice. Yeah, I'm not really sure why it came up in the mid-segment search, but you know, Google's funny that way. It's just a dog hanging out on some ice, and this is a mathematical mid-segment. So here's the idea. This is obviously what we're going to look at today. The mid-segment, what we're going to do is from one side length, we're going to find the midpoint. So these two segments are the same. This is the midpoint. D is the midpoint of AB. For BC, F is going to be the midpoint. That's why there's these midpoints drawn, or these tick marks drawn here. We're then going to connect the midpoint, and this dotted line is called the mid-segment. We're going to check out the properties today of the mid-segment and see how it works for us. So today, our goals. We already kind of talked about identifying polynomials or polygons, points in the coordinate plane, improving properties of quadrilaterals. That's what we did last time, working with coordinate proofs. We're going to continue that just a little bit. We're also going to work on the properties of mid-segments. So here's the mid-segment theorem. This is from your textbook. The segment connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long as that side. So when we talk about segment DE here, this is called the mid-segment. It is parallel to this third side. It's the base, and it's always half this length. I always say the mid-segment is half the base. Mid-segment is half the base. So if this was 10, I would know this would have to be 20. If I knew this was 200 down here, I'd have to say, well, what number is half of 200? Well, that would be 100. The mid-segment is always half the base. Next, the mid-segment of a triangle. What you can do is a triangle is always going to have three mid-segments. Every triangle has three mid-segments. So this is the mid-segment like so, and it is going to be parallel to the base. Secondly, this mid-segment MN is going to be parallel to this part over here of the triangle. And then we'll talk about how this guy over here, I guess, is going to be parallel to this guy over here. So really there's three mid-segments. And there's also, to go along with the three mid-segments, there's also, remember there's something with these lengths. So let's talk about these lengths. This length AB, notice that since M is the midpoint of AB, these two have two tick marks. This part here is also going to have two tick marks. NP is going to be half the length of AB. So if this was 6 and this was 6, the entire length would be 12, and this part down here would just be 6. If I pick another color here, I'll pick red. If we talk about AN and NC, let's just say this is, I'm just going to make some numbers up here. This is 10 and this is 10. That means this MP would also be 10. 10 is going to be half of 20. If I pick a third color here, let me pick blue. We could talk about MN right here being half the length of this total side here. If this was, I don't know, we'll say 7 and this is 7. And this right here is also going to be 7. Each triangle is going to have, you know, these three parts going and coordinating through here. Each of these smaller triangles will have a green side, a red side, and a blue side. Green, red, blue, green, red, blue, as we go along. So actually what happens is we have four triangles that are exactly congruent. That'd be 1, 2, 3, and 4. 4 complete triangles that are completely congruent. That's what happens when you connect all the mid-segments. Let's talk about some practice problems for this. We'll start really easily. If it does say that DE is the mid-segment of triangle ABC, we'll find the values of x. Remember, the mid-segment is always half the distance of the base. So 7 is half of what number? We could say that x is 14. If we jump to 3, x is always half, the midpoint is always, the mid-segment is always half the base. So what number is half of 34? Well, that would be 17. Okay, so this is working, finding the base given the mid-segment, finding the mid-segment given the base. You always say the mid-segment, whatever it is half of whatever the base is. Secondly, in order to form the midsegment, remember we're working with midpoints. That means that E is equidistant from A and C. So if EC is 8, that means 8 x has to equal 8 in this case right here. It's because AE has to be the same distance as EC. Look in this triangle. Again, this is working. We're going to have 4 congruent triangles. Triangle 1, triangle 2, triangle 3, triangle 4. It does give us some given information here. It says that JR is going to be congruent to RK. It's then going to say that KS is going to be congruent to SL. It says that JT is going to be congruent to TL down here. It then wants me to talk about which pieces are parallel. Well, RS is this piece right here. RS is actually going to be parallel to this entire segment here on the bottom, JL. So I'll say JL right here. I'm going to make sure to put a segment on top. ST, let me switch colors. ST is this length right here, ST, and it's going to be parallel to this entire segment over here, JR. I'm sorry, JK. I was JK. So that's why this entire segment here is red and this segment here is red. Thirdly, let me switch to blue. KL, this whole segment here, it's going to be parallel to RT. So RT, make sure to use this segment symbol. Next, we're going to talk about which pieces are congruent. So SL is this part right here. It has 2 tick marks. It's obviously going to be congruent to KS. It's also going to be congruent to this piece right here. I'll put 2 tick marks on it. That's going to be called RT. It's the mid-segment that corresponds to this base over here. JR, we'll switch back to red. JR is this piece right here. It's going to be obviously congruent to RK. RK, because they both have 1 tick mark. And also this red piece right here. So that would be ST. Finally, we'll switch to green. When we talk about JT, that's this piece right here. It'll also be congruent to TL. And finally, to this piece up here, I'll give it 3 tick marks to RS. So it's one way to talk about all these relationships. And each of these triangles, 1, 2, 3, and 4, they all have a red, a green, and a blue side to it. That's another way to kind of think about it and try to see that all 4 of these triangles are all going to be congruent triangles. Next, we're going to use the fact that triangle GHJ, we're going to use this triangle where D, E, and F are all midpoints. What that tells me is in this triangle, this part's congruent to this part's congruent to this part, and this part. If we talk about these bases, we'll have this. Additionally, we'll have this guy, let's see, this guy, and this guy. One way to mark these is always to remember the parallel parts are going to be congruent. So the parts here on the left with the part here on the right of sort of the small triangle. The part on the right over here will be congruent to the part here on the left of this triangle. What's on the bottom here will be congruent to what's on the top of that triangle. And each triangle also needs 1, 2, and 3 tick marks. So what we're going to do is we're going to actually start off with number 14. 14 says that if DE is 4x plus 5 and GJ is 3x plus 25, we're going to try to find the length of DE. So here's the concept here. Remember, the mid segment is always half of the base. So if I was to try to set these equal to each other, I can't straight up set these equal to each other because one of them is bigger than the other. Technically, this one is longer than the other one. It would actually take 2 of these to equal the same length as this entire thing. So in order to write an inequality here, I'm going to have to write 2 times this. So 2 times this is going to equal this entire length here. A lot of students will mix this up and try to put the 2 with this one because they think, well, this one's bigger. Well, you need to actually double the smaller one in order to equal the bigger one. When we distribute, that's 8x plus 10 equals 3x plus 25. I'll subtract 3x from both sides, I'll have 5x. I'll subtract 10 from both sides and have 15. In this case, x equals 5. That's not my answer because the question says, what is DE? So quickly I'll just say this is 4x plus 5 is DE. That's 4 times 5 plus 5, or 20 plus 5. I know that DE, the length, is equal to 25. I'll try this next one really quickly. It says that EF is equal to 2x plus 7. GH is equal to 5x minus 1. Again, if I was to try to set up an equality, 2x plus 7, that's going to be the shorter one, so I'm going to have to double that, is going to have to equal 5x minus 1. Remember, the midsegment is half of the base. So that would be 4x plus 14 equals 5x minus 1. If I move the x's to this side this time, I'll just have an x. If I add 1 to both sides, that would be 15. I'm trying to figure out the length of EF, so that's 2x plus 7. That's 2 times 15, which is 30. 30 plus 7 equals 37. So I'll say EF equals 37. At this time, why don't you pause the recording? Why don't you guys try number 16 on your own, and why don't you try to figure out the length of HJ? Okay, hopefully you gave that a good shot. You should have set up 2x plus 11 equals 8x minus 2. This is the shortest side of the midsegment, so we're going to have to double this side. So that will give us 4x plus 22 equals 8x minus 2. I'll subtract 4x from both sides. That would give me 4x here. I'll add 2 to both sides, so that would be 24. I'll divide both sides by 4, and x equals 6. DF is going to equal, I'm sorry, I'm not looking for DF. I'm looking for HJ. HJ is going to equal 8x minus 2. So 8 times 6 minus 2. 8 times 6 is 48. Minus 2 is 46. So HJ, the length, equals 46. Okay, let's look at this. I don't think this one is really a challenge whatsoever. Some people think it's challenging just because there's a bunch of words up here. It says you have a swing set. This is sort of the side of the swing set. If you were to draw a swing, it would probably come down here like this, and there'd be the other part of the swing kind of connecting here, and you'd swing back and forth, something like that. So as we look at this, it says you are assembling the frame of the swing set. The horizontal crossbars in the kit you receive are each 36 inches long. So this crossbar is going to be 36 inches. You attach the crossbars at the midpoints. So this is a midpoint and this is a midpoint. At the midpoints of the legs. At each end of the frame, how far apart will the bottoms of the legs be from the frame? So basically, how long is this length? Well, if this is a midpoint and this is a midpoint, and you attach this 36, I would say this has to be 72 inches because this crossbar represents the mid-segment of your triangle. So 72 inches because the 36 represents the mid-segment of the triangle. Okay, this is an A-frame. This is a little bit more challenging, not too much more difficult. There used to be a lot of A-frame houses back in the day, and I don't know when that day was. It was before my time, which was probably a long time ago. Anyway, in an A-frame house, the floor of the second level, labeled LM, that's this right here, the second level, is closer to the first floor, NP, this is basically the first floor, than it is to the mid-segment JK. So basically they're saying this is the mid-segment, this is the second floor, this is the first floor, I guess, like so. I don't know if that's really important, but it's okay. If JK, which is the mid-segment, is 14 feet long, this is 14 feet, can LM be 12 feet? Can it be 14? How about 20? How about 24? How about 30? And why don't you explain? Well, here's how I'd tackle the problem. I'd say if this is the mid-segment, well, we know this has to be 28 feet. Okay? If LM is somewhere between 14 and 24, I can just set up some sort of inequality and say that LM has to be between these two numbers. And it can really be anywhere in between there. It could be like a little bit closer up here if this isn't drawn to scale, or it could be a little bit closer down here. So right away I could definitely say, well, no, it's definitely not going to be 12. It's not going to be 14 because that means it'd be the same length as this one. Could it possibly be 20? Well, sure. Could it be 24? Yeah, I think so. But there's no way it could be 30. It needs to be somewhere between 14 and 28. So if this is the mid-segment, this is the base, it has to be twice as long, so it has to be somewhere between the mid-segment and the base. Next, this might be a little bit more challenging just because it's going to be one of these proofs again. And I don't think it's necessarily a two-column proof, and I don't think it's necessarily a coordinate proof. I think it's somewhere in between where we're going to be showing some work here. It gives us the fact that DB bisects angle ABC. So what I'm going to know is I'm going to know this angle is going to equal this angle over here. So these two angles are congruent. I would know that by the definition of angle bisectors. So maybe I'd have these two by the definition of an angle bisector. Secondly, I could go through and I could probably say that this length right here, dB, is congruent to itself. I'd say that's by the reflexive property of congruence. And thirdly, I'm going to try to prove that, say, this side over here is congruent to this side over here. Okay, that's going to be the real test to see if I can do this. So I'm going to try to prove that AB is congruent to BC. That's what I'm going to try to do. So to prove, I'm going to first find the length of AB. To do that, I'm going to use the distance formula. So the distance formula for this would just be C over 2 minus 0 squared plus B minus 0 squared. If I simplify one step, I still have this square root on here. This would be C over 2, this quantity squared, plus B squared. And I'll simplify just one more step here. This would be C squared over 4 plus B squared. I'm going to let that kind of hang out right there. I'm going to see if I need to simplify that any further in just a little while. Next, I'm going to try to find the distance of BC. This should be fairly similar because of what, I mean, B and C are pretty similar coordinates here. So to find the length of BC, I'll just take C minus C over 2. That might be a little more complicated. I'll square that. And I'll add to that 0 minus B, and I'll square that. I'm going to rewrite C as just, so I have common denominators, I'm going to rewrite it as 2C over 2. That's not written very well. That says 2C over 2. When I subtract C over 2, like so. 0 minus B is just going to be negative B, and I'll square that. What I did here is I was just getting common denominators. So I have 2C minus C all over 2. So if I have 2C minus 1C, that would just be C. My common denominator would be 2. Okay, so I had one full C. I subtracted half of a C. How many C's am I left with? Well, I'm just left with half of one. And this would be plus B squared. I can't forget my square root. That's kind of a crucial thing. I'll simplify this one more step here. This would be C squared over 4 plus B squared. Notice that this is the same as this. So I can say something to the effect of, since AB is equal to BC, I can then say something to the effect of AB is congruent to BC. If I was to try to give a reason, like in a two-column proof for something like this, I don't know if I could technically say something about like the distance formula or anything else. It's kind of a weird deal, and that's why it's kind of not really a two-column proof, but it's kind of somewhere between a two-column proof and a coordinate proof. At this point, I can prove these two triangles congruent because I have a side, I have the angle in between, I have another side, so I can prove these two triangles congruent by side, angle, side. Lastly, I want to take a look at these guys. A little bit different than what we've been doing here in the past. It says find the unknown coordinates of the points in the figure, then show that the coordinates of the given statement is true. So we have this triangle and this triangle. Hopefully they're going to be congruent because that really helps us out. If we notice this coordinate is over 0 up k, so I notice this one is also up k, but it's over h, so I can definitely say that this length right here is h. If this length is h, I know that this length has to be h as well. So I would say from 0, if I'm going h in sort of the negative direction, b's coordinate would definitely have to be negative h. And then if I think about how far up am I, well, this coordinate says, the y coordinate says how far up you are. And this says E is up k, C is up k, so I guess B would probably also be up k. That sounds pretty consistent with what I've been doing here. It means this distance right here is k, this distance is h, this distance is h. If I look at this from here up, This distance here is also k. At that point, I could probably say, well, I have a side, I have a side, I have a side over here, I have a side over here, and I probably have some, let's see, I could probably prove some other side to prove this by side, side, side. Otherwise, I could probably say this is a 90-degree angle, this is a 90-degree angle, so I would have side, angle, side to actually prove that these statements are true. What I'm really focusing on is, can you find that coordinate? Number 18 is a little bit more challenging just because we'll work with some fractions. If we take a look and just look at the picture, we start here, we have a nice point at 0, 0, and we're going over a distance of 2h. I would say that would mean that this distance right here is 1h. This is going to be another h over here. So this is over 1h, this is over a second h. That's how we get 2h, 0. And that seems pretty consistent because q is over h, but it's up k. If I think about that, that means I'm probably up about 2 units. I'd say this is probably 1/2 k, and I'd say this first part up here is over 1/2 k. So from 0 up to here is probably 1/2 k, and from 1/2 k all the way up to here is probably also 1/2 k. Okay, so let me take a look at this. Let me keep drawing this. If I'm trying to find these coordinates now, let's look at this guy here. It seems like he's over about half of an h. So I'll say 1/2 h. So from here to here would be 1h. He's only over half of that, so he's over half an h. And how far up is he? Well, the whole thing here is 1k. So I would say he's up 1/2 k. So you could write it as 1/2 k. I could also see somebody writing this might look a little bit neater. It's just h over 2, k over 2 might be a little bit neater. When we talk about t seems like he's over a whole h and then another half of an h. So 1.5 h, another way to write that is 3h over 2 is how far over he is. And how far up, well, I think he's in the same boat here. He's up only half an h. There's a whole h, he's up half that, so we just say, I'm sorry, he's up k. I was trying to say k there. He's up k over 2, just like this coordinate here. This is up k over 2, this is up k over 2. Okay, well now it's time for you. For class, our next class period, what I want you to do is I want you to complete these 2 problems. You can reference them as number 7 and number 8. I want you to draw the picture, and I think drawing the picture will help a little bit. I'm not sure which one's easier, 7 or 8. These are all positive coordinates. I guess this one's a 0 right here. These are all going to be kind of negative in the x direction, but positive in the y direction. So maybe 7 is a little bit harder. But what I want you to do is just fill out each of these coordinates. This would be A, B, C, D, and F. This would be A, B, C, D, E, F. Fill those out. Copy the picture, pause this, and fill out those coordinates. If you want an extra challenge, here's an extra challenge. It just says the midpoints of a triangle are these coordinates right here. Which of the following is not a coordinate of the vertex? I think having some sort of grid or graph paper would be really helpful to do this. So either grid or graph paper would really help you figure this out. Well, I'm not going to tell you what I might do because I'd probably give it all away. So what I want you guys to do is, if you want an extra challenge, try this one, but at least go through and at least try these 2 before our next class. Again, our goals for this class, our goals as we were going along, were actually pretty simple. We were just going to look and identify polygons, points in the coordinate plane. That's what I'm having you guys do before class. Prove the properties of quadrilaterals. We kind of talked about that a little bit. And we really are using the properties of midsegments to determine lengths. In class, we'll get more details, and hopefully you'll be able to do well.